AC machines to three-phase induction motors. Equation relating torque, power, and slip topics are. So here to understand the both power stages in induction motors and to understand the relation between torque, power, and has slip, that is suspense here slip. Power stages in an induction motors, the stator iron losses, that is within bracket in the given, consisting of an eddy currents. The stator current iron losses are consisting of eddy current and hysteresis losses. So here the stator iron loss depends on the supply frequency and the flux density in the iron core. It is practically constant. The iron loss of the rotor is, however, negligible small because frequency of rotor currents under normal running conditions is always small. So here the power stages in an induction motor, the total rotor copper losses, that is equal to 3 into I2 square R2. So here different stages of power development in an induction motor are as under given. So here say this one very carefully, observe this one. So this one, see, observe this one carefully. Here motor input to stator, that is motor input in stator P1, that is next one is stator copper and iron losses, and next one is rotor input P2, and next one is rotor copper losses. So mechanical power developed in rotor PM or gross torque. Next one is windage and friction losses after the output is rotor output, that is in BHP. Now the power stages in a synchronous motor See, see here. Power input to stator copper iron losses, rotor input, rotor copper losses, and then mechanical power developed, friction, windage losses, and which gives the power output. Power output. Here, power input, that is stator copper losses and iron losses. The rotor input, here the power input divided into stator copper losses and iron losses and the rotor input. Then rotor input is rotor copper losses and mechanical power developed. Here mechanical power developed is into two ways, that is friction and windage losses, and which goes the output. Here the losses are stator copper losses and iron losses. In rotor copper losses. In mechanical power losses is friction and windage losses. So power distribution diagram is shown in figure. So for induction motor, observe this one. Observe this one. And a better visual for flow within an induction motor is given. This is the better a visual of a power flow within an induction motor. The torque developed by an induction motor. An induction motor develops gross torque Tg due to gross rotor output Pm. Its value can be expressed either in terms of rotor input P2 or rotor gross output Pm as given below. Now the torque is Tg is equal to P2 by Ws, that is equal to P2 by 2 pi ns. This is the rotor input in terms of. Now the torque, that is in terms of rotor output Pm by 2 pi n. So now here the shaft torque Tsh is due to output power Pout, and which is less than Pm because of rotor friction and windage losses. So here TSH that is equal to P out by W, that is equal to P out by 2 pi n. Now the difference between Tg and TSH equals the torque lost due to friction and windage losses in the motor. In the above expression, N and Ns are in RPS. However, if they are in RPM, the above expression for motor torque become, here they given motor torques Tg and Tsh. So in terms of Tg, that means gross mechanical power developed, P2 by 2 pi ns by 60, that is 60 by 2 p 2 pi, that is equal, here 60 by 2 pi into P2 by ns, that is equal 9.55 P2 by ns Newton meters. Now that is equal Pm by 2 pi n by 60 equal to 60 by 2 pi, that is Pm by n equal to 9.55 Pm by n nm. TSH P out by 2 pi n by 60, that is equal to 60 by 2 pi, it is nothing but P out by n equal to 9.55 P out by n Newton meters. Here Tg gross mechanical torque developed in rotor is 9.55 P2 by ns. In TSH shaft torque is 9.55 P out by n. So here shaft is P out by n and gross torque is P2 by ns. Stator input P1 is equal to stator output plus stator losses. The stator output is transferred entirely inductive to the rotor circuit. Obviously, rotor input P2 is equal to stator output. Rotor gross output Pm is equal to rotor input minus rotor copper losses. Here, this rotor output is converted into mechanical energy and gives rise to gross torque Tg. Out of this gross torque developed, some is lost due to windage and friction losses in the rotor, and the rest appears as the useful or shaft torque TSH. Now here N is a RPS, actual speed of the rotor, and Tg is in the Newton meters. That is Tg into 2 pi n is equal to gross in rotor gross output in watts. Tg is rotor gross output in watts Pm by 2 pi. If there were no copper losses in the rotor, then rotor output will be equal to the rotor input, and the rotor will run at synchronous speed, that is Tg rotor input P2 by 2 pi ns. From the equations 1 and 2 we get rotor gross output Pm is equal to T, that is Tg into 2 pi n, T into omega, Tg into omega, actually Tg into 2 pi n. Rotor input P2 is equal to T omega, that is equal to Tg into 2 pi n s. The difference of the rotor gross output and rotor input equals rotor copper loss. Rotor copper loss P2 minus Pm, that is Tg into 2 pi ns minus n. From 3 and 4th, rotor copper losses, rotor input ns minus n by ns, that is slip. Rotor copper loss is equal to S into rotor input, S into power across the air gap, that is S into P2. Also rotor input is equal to rotor copper loss by S. So rotor gross output Pm input 2 minus rotor copper losses input. Here input minus S into rotor input, that is 1 minus S into input P2. So now rotor gross output Pm is equal to 1 minus S rotor input P2, that is equal to, here rotor gross output Pm by rotor input P2, that is 1 minus S, that is equal to n by ns Pm by Pt is equal to N by Ns. Rotor efficiency is N by Ns. Also, rotor copper losses by rotor gross output, that is S by 1 minus S. So here conclusion is some power P2 is delivered to a rotor, then a part SP2 is lost in the rotor itself as copper losses. So it is appear as heat, and the remaining is 1 minus SP2 appears across gross mechanical power PM, including friction and windage losses. Here PM P2 PM I square R is nothing but, so in terms of S, so 1 minus S, yes, P2 PM PR. This is the rotor input power will always divide itself in this ratio. Hence, it is advantageous to run the motor with as small a slip as possible. Here the summary is this one: gross and torque shaft mechanical power. This discussed.